Good morning.
Good morning, sir.
Shall we start the class or shall we wait? Uh, yeah. So wait a minute. Yeah. So last classes we have seen about the minimizations using the Boolean functions. I mean Boolean laws. What are the laws we have studied? It is De Morgan's law or consensus theorem, and we have different laws which are related to Boolean algebra. Okay, and we have performed kind of minimization operations. So with those Boolean theorems or the theorems what we studied or the postulates what we have seen. Okay, so those are the minimizations how will happen here. So we'll study about this another kind. So we have to study about these forms here, canonical and standard forms. Okay, the canonical and standard forms. So can you see my screen, right? Can you see my screen? Yeah. So the canonical forms and the standard forms. Okay, so I'll let you know what are these canonical forms and the standard forms. Okay, so before going to that, we have to see what is the meaning of Maxterms, sorry, Minterms and Maxterms. We'll use these terms in the coming classes. Okay, so Minterms and Maxterms, so which is very important. Right, so what is the meaning of minterm? You have to know, and what is the meaning of maxterm? You have to know. Okay, you have to identify minterms in a truth table, and you have to identify the maxterms. Okay, so you have to identify. I mean, we have to write the minterms and maxterms of a truth table. Okay, so we have to know all these things. Wait, I think more people are joining. Yeah. So minterms and maxterms. Okay, so what is the meaning of minterm here? So before going to knowing this canonical and standard forms, so we'll know what is a minterm, and we'll be having canonical form of a minterm here, and we'll be having canonical form of a maxterm, and we'll be having standard forms of minterms and standard forms of the maxterms. Okay, so there'll be a canonical form of minterms and maxterms, and there'll be standard form of minterms and maxterms. So we'll see what is the minterm first. Okay, so we had to see what is a minterm. So first of all, if I take any two variables, so x comma y, okay, and output is z. Okay, these two are the inputs. Okay, and this is the output here. This is the output, and this is the input. Okay, so two inputs and one output here. So for two inputs, we have four possibilities: 0, 0.
Sir, screen is not
able to see your screen, sir.
I asked that before, right? ఇప్పుడు కంప్లీట్ చేయలేదా?
నాకు కూడా కనిపిస్తుంది.
అవునా? Some people.
కనిపిస్తుంది, sir.
Yeah, one second. Go for paint. Right. So, so there's a canonical forms and standard. Is it visible, right? Yeah, you can see it all.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so we'll be having two forms here, canonical and standard forms, and these canonical and standard forms, so I'll let you know what is a canonical form and a standard form. So there'll be canonical form of minterms and maxterms, and there'll be standard forms for minterms and maxterms. So we'll see what is a minterm and what is a maxterm right now. Okay, if I consider two inputs here, so xy and if you say any output is like just a random output తీసుకుంటా. So ఏదో ఒకటి random output తీసుకుందాము. Okay, so 0 1. Okay, so 1 0 and 1 1. Okay, and the output is like any kind of output 0 0. So 1 1. So this is the output what we get. I mean, we don't know the equations or we don't know the expressions right now. So these are two table given generally. Okay, so minterm is defined like this. So minterm is also called as minterm is and operation between the inputs here, between the possible input combinations. Possible input combinations. Okay, so what are the four possible combinations here? So for x, y, so the four possible combinations are 0 0 0 1 1 0 and 1 1. So these are the four input possible combinations here. Okay, so it is AND operation between the possible input combinations. So what are the inputs we have here? So two inputs x y, and what are the possible combinations here? 0 0 0 1 1 0 and 1 1, and we have to perform AND operation between these two. Excuse me. So getting my point?
Yes, sir.
Okay, so we have to in the input combinations here. So that is nothing but a minterm here. Okay, that is nothing but a minterm. Okay, so what is the combinations here? So we have to see here. So we x y will be having four combinations here for x y. So 0 0 0 1, so 1 0 and 1 1. Okay, and here 0 0 0 is considered as a complement form and 1 is considered as a normal form. Okay, so 0 is the complement form and 1 is the normal form. So in this case, so what I can write here is x bar y bar is 0 0. Okay, and x bar y is considered as 0 1. Okay, and x y bar is considered as 1 0 and xy is 1 1. Okay, so here you can see the dot operation between these two here. So these are the two possible input combinations. 0 0 is taken as x bar y bar. Okay, so x bar y and y x bar, sorry, x y bar and xy here. Okay, and we are performing the AND operation between the possible input combinations here. Okay, so what are the possible input combinations here? So these four. So these are the AND operations performed between the possible input combinations. Okay, and so here 0 is considered as complement form of input variable. Okay, and 0 is considered as complement form of the input variable. Okay, and 1 is considered as, so 1 is considered as a normal form of input variable. Okay, so this is the thing we have to observe here. So for minterm is AND operation, ANDing operation between the possible input combinations here. So ANDing operation is nothing but the multiplication, that is the dot operation between the possible input combinations. Okay, and here 0 is considered as a complement form and 1 is considered as a normal form of an input variable. Okay, if I consider x here, x is nothing but the normal form. If I want to take the input combination, so here ఇక్కడ 1 ఉంది. సో 1 ని మనము తీసుకోవాలంటే, సో 1 ఎక్కడ ఉంది, x లో ఉంది కాబట్టి it is taken as x here, and here 0 for y it is taken as y bar here. Okay, so these are the combinations how we have to check here. So 0 is the complement form and 1 is the normal form. Okay, so minterm is nothing but the AND operation between the possible input combination. Yeah. So what are the possible input combinations? Okay. So we have to perform AND operation between the possible input combinations. Okay. So this is the thing here. So this is called as a minterm here. Okay. So what we have to do? So when you are given the minterms here, so I'll mention the minterms here. Okay. So I'll be giving some names to the minterms. So minterms is called as M here, small m. Small m will be considered as a minterm. Okay. So possible input combinations same on the 0 0 unte I'll call it as m subscript 0. Okay. So it is considered with the subscript here. Okay. So wait a minute. Okay. So m0 antamu. So next 0 1 combination it is called as so m1. Okay. And 1 0 it is called as m2, and 1 1 it is called as m3. Okay. So these subscripts will represent the value of the input combinations here. Okay, the value of the input combination. So we have the 8421 codes, right? Okay, so 1 and 0 0 0 1. So generally, and it is the combinations we should ignore there. So 3 inputs are 0 0 0 1 1 0 and 1 1. Okay, we have to consider that. And m2 is the combination of 1 0. Okay, and m3 is the combination of 1 1. Okay, so this min term, so m0 is nothing but, okay, so m0 is nothing but it is the ending of input combinations, that is x bar, y bar. X bar, y bar is called as m0. Okay, and x bar y is m1, and x y bar is m2, and xy is m3. Okay, so these are the 4 possible input combinations, and we are performing an operation between the 4 possible input combinations here. Okay, so and so when I consider this truth table, so check this truth table. Okay, so truth table means you find the output of z. I mean, if I want to write a z here, okay, so write the value of z. So z is equal to. So I have to write. So already told you this technique here. So identify the truth table. So whose outputs are equal to 1. So we have to identify the input combinations whose values are equal to 1. So what are the values where it is equal to 1 here? So for this combination, so x is equal to y 1 0 and 1 1. Okay, and we have to perform addition of these input variables here. Okay, so what are the input combinations here? So x y bar plus xy. Okay, or I can write it as, okay, I can write it as, so we'll be having the value of sigma. I don't know whether we'll get it here or not. Okay, so wait a minute. Right, I'll write just like this. That is sigma symbol, you know, right? So sigma of, so what I can write here is, so what is xy bar here? So what is xy bar? So what is the min term here? So what is the min term for xy bar? Xy bar and a min term వస్తుంది ఇక్కడ మనకు
M2, sir.
m2. So it is sigma of, sorry, small m2. Okay, so generally I'll write like this. So m2 and 2 and some sigma of what is the next one? It is 2 and 3. Okay, so see what is the meaning of sigma? So what is sigma? Sigma is nothing, sum of the given terms here. So sum of 2 and 3 here. So what is 2 and 3 is? 2 and 3 are the min terms. Or I can write like this. So m2 plus m3. Okay, m2 plus m3. So these are various forms of representation of this here. Okay, so and this is called as sum of products. Okay, so here sum of the products is there. So we can see there that is equal to, we are having the products here and we are performing some operation of those products. Okay, hence it is called as the sum of the products. So in sum of the products, we'll be having the sum of the Minterms here. So we will be seeing the sum of the Minterms, and we'll be seeing this a sigma. We can represent this with the help of the sigma, and the Minterm should be mentioned in the brackets here. Okay, so getting my point. So generally, so what is the Minterm? Minterm is nothing but the AND operation between the possible input combinations here. So we have to perform AND operation between the possible input combinations. So here Minterms will be having 4 Minterms here. If I have 2 input variables here, we have 4 Minterms: M0, M1, M2, and M3. And if I want to define Z here, if I want to define Z, I had to check for 1 in the output table here, and this is the 1 in the output table, and I had to perform summation of those input combinations whose output is equal to 1. Okay, I have to perform summation of those input combinations whose output is equal to 1. So what are the input combinations which is making output as 1 here? So 1 0 and 1 1. So 1 0 is nothing but it is a Minterm M2, and 1 1 is nothing but it is a Minterm M3, and 1 0 it is also called as XY bar, and 1 1 is called as XY here. We have to perform summation of these two. So XY bar plus XY. Okay, and I can write this XY bar and XY as this also sigma 2 and 3, because it is a summation of 2 Minterms 2 and 3 here, and I can write like this also, M2 plus M3, small m2 plus m3. M2 is nothing but XY bar, okay, and M3 is nothing but XY, and this is called as sum of the products here, sum of the products. And in meantime I can write it as a SOP. It is called as SOP here. So clear?
Yes, sir.
Sir.
Yeah, sir.
Right. So we will see one more term here. Like we'll take the 3 variables here. Okay. So just understand this concept. These are the basic concepts here. So SOP, I'll call it as SOP antano. I'll call it as POS antano, Minterms antano, Maxterms antano. Okay. So you have to know all these terms because you have to understand the basic things here. Because coming classes, so we will use these terms extensively. So some of the products or product of the sums, okay, I'll be using sigma, I'll be using the pi's, okay. So these are the various representations what we will be seeing here, okay. So we'll check all those things, right? So for 3 input combinations, I'll take the 3 inputs as X, Y, Z. Okay, I'll take the 3 inputs as X, Y, and Z. Now output as F here. Our output as F. So first forget about his output. So just take the input combinations here, and I'll take the Minterms here. So the Minterms are represented. Terms and representation. How we represent Minterms. So for 3 inputs we'll be having, 8 combinations. Okay. So for 2 inputs we'll be having 2 power n combinations. For 3 inputs we'll be having 2 power 3 combinations. That is 8 here. So 8 I can write it as 0 0 0 0 1 0. So up to this one it is fine, like 0 1 1. Sorry. 0 0 1. One zero one, 110, 111. So see the values, how many values we have here. For 3 inputs will be having 8 combinations ranging from 0 to 2 power n minus 1. Okay, so ranging from 0 to 2 power n minus 1. So 0 to 2 power n minus 1 is 0 to 7. So we'll be having the values from 0 to 7 only, but we'll be having total of 8 including 0. Okay, this is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, and 111. Okay, so these are the 8 possible input combinations for 3 input variables. Okay, so what are the terms here? So I told you 0 is a complement term and 1 is a normal term here. So what is the term here? So I'll write it as x bar, y bar, z bar. Okay, and tell me the next ones. What are the next ones?
X bar, Y bar.
Bar, y bar, z. And here it is x bar, y,
Z
z bar. So 0 is a complement form, 1 is a normal form. So x bar, y, z. And you can see the dot operation. So here I'm writing like this. So it is a dot operation between all the input combinations here. Okay, this x, y, y bar, z bar. X, y bar, z. And it is x, y, z bar. Okay, and it is x, y, z. Okay, and representation, how to represent this Minterms here. So it is small m naught. Okay, in a similar way, m1. So here it is m2. M3, M4, M5. This is M6 and this is M7. Okay, and this is the Minterms here. Okay, so these are the Minterms for 3 input combinations. We'll be having 7 Minterms here. Okay, and if I give any function like this, if I want to get that function there, okay, so if I write the function f1, okay, so I will represent 2 terms f1 and f2 and tell me the equations for f1 and f2. Okay, so tell me the equations for f1 and f2.
Sir, join and change.
What?
Admit and చేయండి.
Only one? So actually there is auto admit option, but I don't know, sometimes it will be stuck. So no need to myself MGR awesome. Okay, yeah, fine. Is there anyone waiting?
Yes, sir.
Go ahead, Jeshna. So let me know, like I'll once again join, because you know sometimes these network issues will be there, so we can't join the people. So let me know if there is anyone waiting.
No, sir. Join.
No, okay, fine, fine. Right. So so these are the Minterms here, and if I write a truth table, I mean, forget all about this M0, M1, M2, even you only so if I write a truth table, so generally we'll be having the truth tables like this. Okay, so 0, 1. So I need the functions of f1 and f2. So tell me the equations for f1 and f2. Okay, so I'll be writing this. Tell me the equation for f1 now. So quick. So minimization sarvajudamu. So first of all, I need a equation for f1 and f1 here. Okay, so there's a truth table. So what we are taking the truth table here is, we have to check what we have to check here. So we have to check the these are the output sections here. Okay, so these are the output sections. We have to check the outputs. Okay, so where it is equal to 1. So output second one on 9. So these are the ones here, and here it is 1. Okay, so F1 is summation of the input combinations. Okay, so whose output is equal to 1. Okay, or F1 and F2. When we are writing this Minterms here, or sum of the products. Okay, when I talk about the Minterms, it is sum of the products. Okay, so when I talk about the sum of the products, we have to add the Minterms. We have to add the Minterms whose output is equal to 1. So what are the outputs which are equal to 1 here? So this is equal to 1. So hence it is M1, and this is equal to 1 here. So M1 plus M2 plus this is equal to 1, M5. Okay, so I can write F1 as like this. So F1 is equal to, okay, so F1 is equal to, what are the values there? So M1 plus
M2
M2 plus M5. So what is M1?
5.
What is M1? So M1 is X bar, Y bar, Z, and what is M2? So X bar, Y, X bar, Y, Z bar, and what is M5? So what is M5 is 1101. It is X, Y bar, Z here. Okay, so this is how do we have to write the Boolean functions here. So then we'll go for the simplifications, or we'll draw the logic diagrams. So whatever. So these are the simplifications what we had to do here. Okay, so we have to check the simplifications like this. Okay, so if you are given a truth table like this, I need an equation for F1. So this is how we have to write this F1 here. So then we can go for the further simplifications. Okay, so or else no problem. So if you are asked like this, mention the Minterms. So you have to mention these Minterms here. Okay, so F1 is a sigma of F1 is, so wait a minute. So F1 is a sigma of, so what are the terms here? 1, 2, 5. So 1, 2, 5. So it's summation of, so minterm 1. So we had to write M here. Okay, summation of minterm 1, 2, and 5 here. So getting my point?
Yes, sir.
Okay, so this is a minterm here. So now we'll see the Maxterms. Okay, so Maxterm is a complement of minterm. So what is the meaning of complement? So how to take the complement?
Reverse.
So yeah, tell me. So what is the complement of, for example, if I say that, so there's a minterm here. So if I want to complement this maxterm. So what happens if I complement this maxterm? I mean minterm. So complement is same outundi. M not complement is same outundi. So what are the values here? So the complement, so XYZ will be 1, 1, 1. Okay, okay, and here the terms will be the same here. So 1 is a normal form. I mean the 1 is a complement form, and 0 is the normal form here. So in case of the Maxterms, okay, so I'll check about this Maxterms here. So in Maxterms, so 0 is a normal form. Okay, and 1 is complement form. Okay, so and Maxterms, complement of minterms, give Maxterms. Okay, so complement what we have to do. So generally convert, we can obtain this with the help of duality. So duality and so change place to dot and dot to plus and 1 to 0 and 0 to 1. Okay, and afterwards complements each and every literal. Okay, for example, if I take the input combinations like this, so 0, 0, 0, or the input combination. So what I can write in Minterms, so I can write as x bar, y bar, z bar. If I want to take the complement of this, the complement will be like this. So 1, first obtain the duality. So 1 1 1. Okay, so change 1 to 0 and 0 to 1. So first change complement రావాలంటే మనకు first find the duality of the each and every term here. So duality means so changing 0 to 1 and 1 to 0. Okay, and changing dot to plus and plus to dot here. Okay, so with duality, so what I can find here is, so I can x bar plus, so y bar plus z bar. So this is the duality, and if I want the complement, so complement each and every literal annum. So literal ante these are the literals here. Okay, so x bar, y bar and z bar only. So I'll write it as x plus y plus, sorry, 1 minute. Yeah, and complement each and every literal. So 0, so this is also possible here. So again it is a 0 0 0. Okay, so duality తీసుకుంటాము, తర్వాత complement తీసుకుంటాము, and it is the final complement of this one here. I'm getting my point here. So first of all, this is duality. So duality em chestamu, duality ante so take xyz only. Okay, so take the values of, so x bar, y bar, x bar, y bar, z bar. So this is minterm m naught. Okay, and minterm, take the complement of minterm m naught, will get the max term here. So the complementing is nothing but, so first find dual of the above. Okay, so dual ante it is nothing but x bar plus y bar plus z bar. Okay, and afterwards complement each and every literal. Okay, so the complementing each and every literal will give here x plus, so y plus z. Okay, and what I told you here is in max terms 0 is the normal form and 1 is the complement form here. Okay, so 0 is the normal form and 1 is the complement form. So what is this x plus y plus z here? It is the input combinations of 0 0 and 0. Input combinations of 0 0 and 0. And max term is defined as, it is OR operation of possible input combination. So what is the minterm? What is the minterm? So minterm is AND operation of possible input combinations, where max term is a OR operation of the input combinations. We have to perform OR operation of the possible input combination. So if I say that inputs are 0 0 0, okay, I have to perform OR operation of the possible input combinations. So I have to perform this, and you can check here. So 0 is a normal ga, in case of minterms it is a bar complement form, and in case of max term it is a normal form. Okay, so what I said here is, so max term, this is max term is equal to, so I'll represent it as capital M0. Okay, so M0 is a OR operation of the possible input combination. So what are the input combinations here? 0 0 0 are the input combinations. If I perform AND operation here, okay, so it has to be like this. So 0 is the normal form here. So 0 stands for x here. So the other 0 stands for y, another 0 stands for z here. So I have to perform OR operation. OR operation is nothing but the plus operation of these three here. Okay, so hence it is m0 here. So getting my point? It is the reverse of the minterms here. So here, there it is a OR AND operation, here it is a OR operation. So here 0 is the normal form here, there 0 is the complement form, and here 1 is the complement form, and there 1 is the normal form. Okay, and here we are performing the OR operation of the input combinations. There in case of max terms, you are performing the AND operation of the input combinations. Okay, so this is the thing here. So we will check a table here. Okay, so we'll check a table. So table will be like this: X, Y, Z combinations. The same case, or else yeah, like this. So we'll take a big table. So I'll mention the difference between minterms and maxterms. So 1, 2, 3, 4, 5, 6, 7. Okay, so here term is X, Y, Z. Okay, and term representation and so we'll see the difference between minterms and maxterms here. Okay, this is for minterm, this is for the maxterm, and I'll write an F here. So F is a function, F1 and Tanu. So we'll see how the outputs are checked also. Okay, so what are the 4 possible input combinations here? I mean, we'll be having 3 inputs here. So 3 inputs. Okay, so 3 inputs, like we'll be having 8 combinations: 0, 0, 0. Okay, so 0, 1, 0, 0, 1, 1. So 1, 0, 0. Sorry, I forgot 0, 0, 1 here. So 0, 0, 1. So 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so for 3 inputs, we'll be having 8 input combinations here. What are the terms here? I told you, like it is X bar, Y bar, Z bar. Okay, and representation is small m naught. Okay, so here in case of maxterms, so it is, so what is a maxterm lo enti manaku? It is a combination. So 0 is the normal form. Okay, and 0 is the normal form. Okay, and 1 is the complement form. So normal form kabatti it's not X bar here, it is X plus so Y plus Z. Okay, and representation I can write it as M naught. Okay, in a similar way, so what is the second one here? It is X bar
Y bar X, Y bar Z.
Y bar Z here. So it is a term M1. Okay, so term M1. Wait a minute. Right, and this is, so 0 is the normal form and 1 is the complement form. Okay, and 1 is the complement form. So hence 1 ochindi kabatti I'll write it as Z bar. Okay, and this will be M1. In a similar way, we are having all these terms. So it is M2. This is going for capitalization. M2, M3, M4, M5, M6, M7. Okay, and this will be M2, M3, M4, M5, M6, and M7. These will be capital letters. Okay, and the terms will be like this. So here one X, Y, Z, and here it will be X, Y, Z bar, and here it is X, Y bar, Z. Okay, and here it is X, Y bar, Z bar, and here it is X bar, Y, Z, and here it is X bar, Y, Z bar. Okay, so these are the normal forms and the complement forms in case of the Minterms here. And coming to the Maxterms, reverse of this. Okay, reverse of the things here. So X is the normal form, and Z is the 0 is the normal form, and Z is the complement form here. Okay, you can check here. Z is 0, 1, 0, and 0 is the normal form. So 1 is the complement form, and so 1 is the complement form, and again 0 is the normal form here. Okay, and what is the next one here? So 0, 1, 1, 0 is a normal form. So 1 is the complement form, and 1 is the complement form. Okay, and 1, 0, 0. So 1 is the complement form. So 1 is the complement form. It is 1 here. So complement, and 0, 0 are the normal forms. Okay, and 1, 0, 1. Two complements, X bar and Z bar. So Y is the normal form. Okay, and we'll be having 1, 1, 0. So 1, 1, 0 and 10, two complements. So 1, 1, and this is 0. Okay, and the last one, so 1, 1, 1. So all of them are complements. So X bar, Y bar, and Z bar. Getting my point?
Yes, sir.
Minterms are nothing but or AND operation of inputs. Okay, and Maxterm is nothing but
Or operation.
OR of inputs. Okay, and if I take any random function, so ఏదో ఒకటి assume చేసుకున్నాను ఇక్కడ. So 0. So f is like this. So 0, 1, 0. So ఇక్కడ కూడా మనం ఫంక్షన్ రాసేటప్పుడు రివర్స్ తీసుకోవాలి. Okay, so if I want to write a function, I have to write a function in two ways here. So one is sum of the products, other one is product of the sums. Okay, so those are the input combinations. So f in sum of the products. Okay, so sum of the products, and I have to check for ones here. Okay, so one in the table here. So where f is equal to 1 for these input combinations. So this one, this one, this one, this one, and this one. So what are the Minterms here? So f is equal to, okay, so it has the Minterms are nothing but, so Minterms are nothing but, so here for Minterm, M0, M2, M4, M5, M7. Okay, so M0 plus M2 plus M4 plus M5 plus M7. So that is equal to sigma of sigma small m of, so 0, 2, 4, 5, 7. Okay, so input combinations you can write, right? So 0 and it is X bar, Y bar, Z bar. 0, 2 is nothing but X bar, Y, Z bar. So we can write the summation of all those. Okay, so this is sum of the products, and so f in product of sums, f in product of the sum. So here we have to check the, here we check for 1 year in case of sum of the products. So in case of product of sums, we have to check for zeros, but to check the tables where whose output are equal to 0, and we'll perform the OR operation of those input combinations. Okay, so here the Maxterms are, so M1, so consider for zeros here. So zeros ఏవైతే ఉన్నాయో వాటి కన్సిడర్ చేయాలి. Okay, so 0 for M1 it is a 0. So max term is M1. So earlier it was plus here, here it is dot, product of the sums here. So M1 and here M3.
M6.
Yeah, so dot M6. Okay, so what I have to write here, it is a product of sums. The product of sums got it is pi here. So pi is the product of sums here. So pi M. So sometimes we can write capital letters. Sorry. So it is capital M. Okay, so pi of 136. Okay, and it should be written like this. So what is M1? Generally, M1 is nothing but it is 001 here. So 001 ante, so 0 is the normal form and 1 is the complement form. It is x plus y plus z bar. Okay, into, so that the into is nothing but dot here. Okay, so 3 is nothing but 0 1 1. So 1 is the complement form and 0 is the normal form. So it is x plus y bar plus z bar. Okay, and the next one is 6 here. So 6 is nothing but, so 1 1 0 here. So it is x bar plus y bar plus z. Okay, you can see here. So earlier it was a product of sums. So and this is the sum of the earlier it was sum of the products, and here it is the product of sums here. So these are the sums and we are performing the product of these sums here. Product of these sums. So it is written as pi of max terms, so 136. So what are the min terms we'll be having here? So apart from max terms kanukovalante, so other than these terms are the max terms. Okay, if you are asked like this, so first of all find the min terms and remaining terms are the max terms. Okay, so 0 2 4 5 7 undi. So what are the remaining terms here? So 1 3 6 here. So 1 3 6 are the max terms. Okay, so max terms are nothing but a product of sums. So most probably we'll prefer the sum of the products. If you are asked about the product of sums, I have to do that. Okay, so truth table lo 0 ki manamu ఈక్వేషన్ ఫైండ్ అవుట్ చేయాలి. లైక్ ట్రూ టేబుల్స్ జీరోస్ ఏవైతే ఉన్నాయో సో అవి సమ్స్ ఉంటాయి, ఆ సమ్స్ ని మల్టిప్లై చేయాలి ఇక్కడ ఇన్ కేస్ ఆఫ్ ద మ్యాక్స్ టర్మ్స్ హియర్. క్లియర్?
Yes, sir.
Okay.
Yes, sir.
Yeah. Okay, and we need some canonical form and standard form. So canonical form ante, so which will include all the terms here. So this is the canonical forms here. So canonical forms, and I can check here. Okay, so each product is having all the input variables here. So whether it is a normal form or the complement forms. Okay, so here I have x here, y here, z here. Okay, and here also I have x, y, z. I mean each and every combination. So canonical forms low. So each and every input variable is covered here. It's not a minimized one here. So it consists of all the input variables in normal form or the complement form. Okay, so that is called as a canonical form. Right. So canonical form. If I say that canonical sum of the products. Okay, sum of the products. Okay, so this sum of the product will have all the input variables in normal form or complement form. Okay, for example, we say that small n naught plus m1 plus m5. Okay, so what I can write here is m naught is nothing but x bar, y bar, z bar. So M1 is 001 X bar, Y bar Z, and M5 is X bar, Y, 101 X Y bar Z here. Okay, and you can see here. So here the terms are not missing. If I don't mention any kind of Minterms also, it is the expression here. So F is equal to. So this is the equation. Okay. So this is in canonical form of standards are some of the products here. So canonical form. Okay. So canonical SOP here. So canonical SOP is nothing but each and every thing here. So is having each and every input combination. So X, Y, Z is there in normal form or the complement form here. Okay. So if any one of them is missing, like, so F is equal to, if I write it as X plus Y bar Z. Okay. So this is called as a standard form here. Okay. So here it is not mandatory for having each and every input combinations here. Okay. So it may contain like the functions, the terms, the term of the functions may contain 1, 2, or any number of literals here. So here I have only one literal. Here I have 2 literals here. So it's not mandatory to have all the input variables here. To have all the literals here, all the literals in case of the standard forms. Whereas in a canonical form, each and every literal should be available, whether it is in a complement form or whether it is a normal form here. Okay. So got the point. Just a simple definition at the done check code depth just if I are given like standard sum of the products and standard sum of the products. So it is a normal equation. So where 1 or 2 terms or 1 or 2 literals may be missing, or it has all the literals, anything is fine. Okay. So that is called as the standard form. So if it has all the literals, so a normal form or the complement form, it is called as canonical form. Clear?
Yes, sir.
Okay, so those are 2 forms here. So we'll see 1 or 2 problems. You'll understand those things here. Okay, so what is how to convert the standard form into canonical form? All we can know that. Okay, so take down this problem. So express the Boolean function. Function f is equal to a plus b bar c as a sum of Minterms. The function as so this is the problem here. So express the Boolean function. So f is equal to a plus b bar c as sum of Minterms. Okay. So I need this function as sum of Minterms. So this is the standard form here because it has 3 variables, but a low bc miss ayindi and next low bc low, and we are missing this a here. Okay. So this is the standard form here. We have to convert that into a canonical form. After converting that into a canonical form, so we'll find what are the Minterms that are required to form this sum here. Okay. So a plus b bar c undi. So దీంట్లో నేను sum of Minterms కనుక్కోవాలి. So Minterms అంటే ఏంటి? So sum of the products. So sum of the products అంటే like I need to find m0, m1, m2. So what are the Minterms which are responsible for this thing here? Okay. So there are 2 ways here. Okay. There are 2 ways. Okay. So first I will tell the one way. So first of all, write the truth table for this. Okay. So what I'll do here is, so write the truth table for this. So what are the input combinations? Input combinations are A, B, C, and I'll write the value of F. Okay. So input combinations. So 3 inputs I got it. What are the input combinations we can get here? So what are the input combinations we can get? So there are 2 methods. So 1, 1, 1. Okay. First of all, write all the input combinations here and substitute these values. So substitute these values of 0, 0, 0 in F here. Okay, so ఏమొస్తుంది మనకి ఇక్కడ? So 0 0 it is 0. Okay, and a plus b bar c లో substitute చేయాలి. So these values ni. Okay, so a is 0 fine plus b bar c, so uh, b is 0 here, so we'll get a 1 here, and c is 1, so f is equal to 1 here. Okay, so similar way substitute all the values. I'll get these values here, so 1 1 1 1. Okay, so this is the Boolean function, and this is the output of each Boolean function. So what I told here, I have to express this Boolean function as sum of the minterms here. So sum of the minterms, and I have to identify the minterms. Okay, so which is making this equation. So what are the minterms whose value is equal to 1? What are the minterms whose value is equal to 1? So minterms is equal to, this is the one here. Okay, so this is small, yeah, m1. I have to identify the minterms which are making this f is equal to 1. So this is m4, so m5, m6, m7. Okay, so f1 is f is equal to m1 plus m4 plus, so m5 plus m7. Okay, so that is equal to sigma of, you know, these things. Okay, so sigma of I can write small m, or I can write directly here. So sigma is 1 4 5 7. Okay, so this is a simpler method. There's another method also, I'll discuss that. So those are also essential. Okay, so if you are given like this, given the equation, standard equation, and sum of the products, and find the sum of minterms. So find the truth table. Okay, so truth table is nothing but, so we'll take the input combinations, possible input combinations, and substitute those values in the equation, given equation. So I'll get the outputs here, and if I want to find the sum of the minterms here, so if I need to check the f here, I need to check the output. So whose outputs are equal to 1, I need to add those input combinations there. Okay, so this is the thing here. So this is the, what are the minterms here? So 1 4 5 7 here. 1 4 5 7 are the minterms. Okay, so this is another term here, so another method. So do you understand this? This is fine, right?
Yes, sir.
Yes, sir.
The max terms, if I know the minterms, what is the max term? So what are the max terms here?
0 2 3 6.
Yeah, 0 2 3 is no 6, 0 to 3. Okay, it is nothing but 0 2 3. So 1 minute. Yeah, sorry, I got a call. So attendance ఇంకా ఏమని చెప్పలేదు నేను. సో ఇంకా అటెండెన్స్ డ్రాప్ చేయమని చెప్పలేదు కదా. సో డోంట్ బి ఓవర్ స్మార్ట్ మ్యాన్. అటెండెన్స్ కోసమే వస్తున్నట్టు ప్రూవ్ చేయొద్దండి. ఐ నో మీరు అటెండెన్స్ కోసమే వస్తారని, బట్ దెల్ బి ఫ్యూ పీపుల్ రైట్. సో అట్లీస్ట్ దెల్ బి 5 to 6 people or 10 people. సో 10 people ఉండర్లేదు నాకు తెలిసి మీ క్లాస్ లో. I think this is the class where I get minimum response. Right? If it is an offline class, it could be fine. But మీకు ఆన్లైన్ అంటే మీకు ఒక టైం పాస్ అయిపోయింది, రైట్? సో రావడము, ఆన్లైన్ లాగిన్ అవ్వడము, పక్కన పెట్టడం. సో ఇట్స్ ఫైన్. సో దట్ ఈస్ నన్ ఆఫ్ మై బిజినెస్ as of now, not in offline class, right? So online class, I can't create the seriousness. Well, I can create it, but the syllabus is very vast. I don't have time to create seriousness. Okay. So when it is offline class, I'll definitely create that seriousness, right? Fine. So this is the Minterms here, and the Maxterms are nothing but, so Maxterms are 0, 100. So those are the max. Okay, you getting my point?
Yes, sir.
Okay, so and there is another method. So we'll bind it up fast. So we'll be having next class match in the gartis. Parle rose start తీసుకుంటారు కదా, ఇంకో 5 నిమిషాలు అయితే ఏం కాదు. ఓకే,
ఎల్ఎస్ ఉంది సార్ ఇప్పుడు.
లేసా?
ఎస్ సార్.
9:30 కదా, కాదా? 9:20 కే?
Yes, sir.
9:21, sir.
Yeah, no problem. So we'll do one thing. We'll stop it for here. Okay. So tomorrow is second Saturday, but we'll take class. Okay. So morning session, we'll take class for mother disturbance. I'll take it for 2 hours.
Okay, sir.
Yeah. Tomorrow, don't miss the class. Tomorrow we are going to discuss one of the interesting topics and one of the best topics, and a very, very important topic also. So simplification. So meeku anni cheppanu kada, simplifications, best of the best simplification. We'll get that with the help of another method. Okay. So that method is very, very important. So don't miss tomorrow's class. 99% I'll be taking the class. 1% I don't know. If I have any other commitments, I'll let you know. So Saturday and Sunday, most probably I'll take the classes on Saturday and Sunday, because I need continuous hours, like 2 hours. So we are very slow, I think, but it's fine. Okay. So drop your attendance and can leave. Yeah.